Now that you've had a chance to take a deeper look at what a system of equations is and what a solution to a system is, let's take a look at how to check a solution. So we're going to walk through problem 1 together. I'm going to do 1A and you're going to watch and listen. Together we're going to do 1B, and then you're going to pause the video and try 1C on your own. After you've completed 1C, you will resume playing the video to check your answer. So here we go. Problem number 1. Are the following ordered pairs solutions to the given system? So ordered pairs meaning an x and a y together, so that's those guys. Are they solutions to the system? So a system is 2 or more equations with the same variables, and a solution is an ordered pair that makes both equations true. So let's start with 1A. Is 0, 1 a solution? Well, 0 is the x and 1 is the y, so we plug those into the first equation. So it'll be 3 times x, which is 0, minus 6 times y, which is 1, equals negative 3. And then we simplify to check this. 3 times 0 is 0, 6 times 1 is 6, 0 minus 6 is negative 6, so we end up with negative 6 equals negative 3, which is not true. So 0, 1 is not a solution to the first equation, so therefore it is not a solution to the system, because to be a solution to the system it has to work in both. So not a solution because 0, 1 does not make both equations true. And you might be asking yourself, well, what if it worked in the second one? It doesn't matter. To be a solution, it has to work in both. So as long as it doesn't work in the first one, it's not a solution. Okay, now's the time for you to get out your paper and pencil, because we are going to work on problem 1B together. So on to 1B. We're now trying to figure out if 4, 2 is a solution to our system. So just like we did in 1A, we will plug 4 in for x and 2 in for y, and we'll just start with the first equation. So we'll end up with 3 times 4 minus 6 times 2 equals negative 3. And then to check this, we just simplify. So 3 times 4 is 12, 6 times 2 is 12, and then the next line we have 12 minus 12, which is 0, and we bring down the equal sign and the negative 3, and that is not a true statement. 0 does not equal negative 3, so therefore we know that 4, 2 is not a solution because it does not make both equations true. If you would have happened to start by checking with the second equation, the x minus 2 equals y, and you plugged in your 4, 2, so 4 minus 2 equals 2, you would end up with a true statement. But the ordered pair 4, 2 only works in the second equation. It does not work in the first equation, so it is not a solution because it does not work in both equations. Okay, now it's your turn to take a try on 1C. So you'll work this out on your own, and when you've finished or you've gotten to a point where you are stuck, continue watching the video to check your answer or to give yourself some assistance. Now that you've had a chance to try problem 1C on your own, let's take a quick look at the correct work and answer so that you can check your work. Okay, for 1C we were looking to see if 3, 1 was a solution to our system. So we plug 3 in for x and 1 in for y in the first equation, and we simplify. So we end up with 9 minus 6 equals negative 3, which is 3 equals negative 3, which is not true. So therefore 3, 1 is not a solution. So just by making one of the equations not work, it's not a solution. However, if you would have started with the second equation of x minus 2 equals y, if you would have started with this equation and you plugged in 3 for x and 1 for y, you would have gotten a true statement. So it works in one of the equations, but it doesn't work in both. So you still have not a solution. Okay, let's go on and try problem number 2 now. For this problem, we will read through the question and I will give you a few suggestions, and then you will pause the video and you will come up with a solution on your own, and then after that you will continue watching the video to check your work. So here we go. Number 2, use the graph to find the solution to the given system. So the given system is y equals 2x plus 3 and y equals negative 4x minus 3. So if you take a look at the graph, the blue line is the y equals negative 4x minus 3, and the red line is the graph of y equals 2x plus 3. So using your knowledge from this lesson, you will now pause the video and find a solution and check it. Okay, by looking at the graph, you should identify that your solution is the point where the two lines cross. It is the one ordered pair that is on both lines, and that ordered pair is negative 1, 1. So by looking at the graph, we believe the solution is negative 1, 1. So in order to check this, all we have to do is plug it into both equations and make sure it makes both equations true. So if we start with y equals 2x plus 3, and we plug negative 1 in for x and 1 in for y, we end up with 1 equals 2 times negative 1 plus 3. And then to check, we simplify. So we have 1 equals 2 times negative 1 is negative 2. Bring down the plus 3. Negative 2 plus 3 is 1, so we end up with 1 equals 1, which is a true statement. So know that we're somewhat along the right path because our solution at least works in one equation. So let's check it out in the second equation. So if we look at y equals negative 4x minus 3, and we plug in 1 for y and negative 1 for x, and then we simplify. So we have 1 equals negative 4 times negative 1 is 4. Bring down the subtract 3. And 1 equals 4 minus 3, which is 1, which is also true. So when we plugged in our solution to both equations, it made both of them true. So therefore, negative 1, 1 is the solution to the system because it makes both equations true. Okay, now it's time for your quiz.